So welcome back to another session. So in the previous session we have discussed exercise 11.3. So today we will discuss exercise 11.4. But before going to the this exercise, so we have some identities. So the first identity we have is sin square theta plus cos square theta is equals to 1. And second one we have is secant square theta minus tan square theta is equals to 1, and cosecant square theta minus cot square theta is equals to 1. So these three identities we have. So these are important three identities. You should remember these three, right? So let us discuss the first one. So how we got these values? Sin square theta plus cot square theta is equals to 1. So how we got those values? Let us discuss that in detail. Okay, so let us take a rectangle triangle. So let us take a triangle. So this triangle is A, B, and C. So from the angle C, okay, from the angle C, so if what is AP? AP will be opposite side. This side will be opposite to this angle. So this side will be opposite to this angle, and BC will be your adjacent side, and AC will be your hypotenuse, right? AC will be your hypotenuse. So we know that Pythagoras theorem, right? So Pythagoras theorem. What is the Pythagoras theorem? So adjacent side square plus opposite side square is equals to hypotenuse square, right? Hypotenuse square. So what is adjacent side here? BC, right? Adjacent side is BC. So BC plus opposite side. What is the opposite side? Opposite side is AB. So AB is your opposite side. This is equal to hypotenuse is AC. Hypotenuse is AC. So all the squares. Now what you have to do is divide uh, AC on AC square on both sides. Okay. So when you divide, so BC square by AC square plus AB square plus AC square, which is equals to AC square by AC square. Right. So these two will get cancelled, and this one BC. Remember what is BC? BC is adjacent side, right? So adjacent side, adjacent side, right? BC is what? BC is the adjacent side. So here we have square, so square. AC is hypotenuse square plus opposite by what is this is at AC is hypotenuse square is equals to 1. Now adjacent by hypotenuse is nothing but your cos theta, as we have square, so cos square theta, and opposite by hypotenuse is nothing but your sin theta, as we have square, so we take square is equals to 1. right? So this is how we got cos square theta plus sin square theta is equals to 1, right? So in similar fashion, you can divide with, here we have divided with the hypotenuse, right? So you can divide with opposite side or you can divide it with adjacent side. So when you divide it, you will get the other two identities, right? Okay. So let's go to exercise. So exercise 4 point, sorry, exercise 11.4. First question, question number 1, first bit. So what we have in exercise 11.4. So what we have, simplify the following. The first one is 1 plus tan theta plus secant theta into 1 plus cos theta minus cosecant theta. And second one we have sin theta plus cos theta whole square plus sin theta minus cos theta whole square and secant square theta minus 1 and cosecant square theta minus 1. Right. So first let me write the question number 1 first. Question number 1 first bit. So 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. Right? You can see here exercise 7.4. So simplify the following. So tan theta 1 plus tan theta plus secant theta into 1 by 1 plus cot theta minus cosecant theta. Let's discuss this one now and then we'll move on to the next ones. Right? Okay. So solution. So 1 plus tan theta, I'm writing it as sin theta by cos theta plus secant is nothing but I'm writing it as 1 by cos theta into 1 plus cot theta is nothing but cos theta by sin theta plus cosecant is nothing but 1 by sin theta. Okay, so here LCM is cos theta. So cos theta into 1 is nothing but cos theta plus sin theta plus 1 into, here the denominator, the LCM is sin theta. So here sin theta plus cos theta plus this one will be minus, right? So here minus, so this one is also minus 1, right? Minus 1. Now multiply these two. So when you multiply these two, so Okay, so where we are? So we have multiplied. We have to multiply these two. So sin theta cos theta plus 1 and sin theta cos theta. So this one we can write it as, so sin theta plus cos theta plus 1 and into sin theta plus cos theta minus 1 whole divided by sin theta into, or you can directly write sin theta cos theta. Okay, now if you see here, consider this part as A and this part as B. Okay, and therefore so this part from here to here it will become A, and from here to here it will become B. So this is in a form of A plus B into A minus, so A minus B, which is equals to A square minus B square. Okay, so which is in a form of A square minus B square. So right up A square. What is A? Sin theta plus cos theta whole square is A minus, what is B? B is 1 whole square um, divided by sin theta cos theta. Okay, divided by sin theta cos theta. Now this is in a form of A plus B whole square, which is equals to A square plus B square plus 2AB. Okay, A square plus B square plus 2AB. So what is A? A is sin theta and B is cos theta. Okay, so sin square theta plus cos square theta plus 2 sin theta cos theta divided by sin theta cos theta, and here we have minus 1 whole square, so write it as minus 1. Okay, so we have sin theta plus cos square theta uh, is equals to 1. Right, sin square theta and cos square theta is equals to 1. So this one is sin square theta plus cos square theta is equals to 1 we have. So sin square theta plus cos theta is equals to 1 plus 2 sin theta cos theta minus 1 divided 1 minus 1. So So we have 2 sin theta cos theta divided by sin theta and cos theta. So sin theta gets cancelled, and cos theta will get cancelled, and which is equals to 2. So this is your answer, right? And next one, the second bit we have is sin theta plus cos theta whole square, sin theta plus cos theta whole square plus sin theta minus cos theta whole square. Okay. So we have the formulas. A plus b whole square is equals to a square plus b square plus 2ab, and a minus b whole square is equals to a square plus b square minus 2ab, right? So substitute this. So sin is a here, cos is b. So sin square theta plus cos square theta plus 2, so 2 sin theta cos theta plus sin square theta plus cos square theta minus 2 sin theta cos theta. Okay, so which is equals to, so here sin square theta plus cos square theta, sin square theta plus cos square theta. So we have it as, so this one is 1 plus 1, and here, so 2 sin theta cos theta, 2 sin theta cos theta will get cancelled. So this is equals to 1 plus 1 is 2. Right? 1 plus 1 is equals to 2. Similarly, the third bit, let's jump to the third bit. 2. So third bit is given as secant square theta minus 1 into cosecant square theta minus 1. Okay, so we know that tan square theta is equals to secant square theta minus 1, and cot square theta is equals to cosecant square theta minus 1. Right? Okay, so substitute secant square theta minus 1 is tan square theta into cosecant square theta minus 1 is cot square theta, right? So this is equals to, as these two, tan theta and cos theta, are inverse to each other, so which means tan square theta into 1 by tan square theta. So this one will get cancelled and we are left with 1. Right? So how you got this one, which is, I have used the same identity, the second and third identity. So this is secant square theta is equals to tan square theta minus 1. Okay, secant square theta is equals to tan square minus 1. No, secant square theta minus tan square theta is equals to 1, and here this one, cosecant square theta minus cot square theta is equals to 1. So using these two identities, so I have shuffled it, and we can get it and substitute the values, so we will get the answer, right? So let's stop here. We'll see you in the next video for the question number 2 and so.